What makes survival analysis so special? Let me tell you. Think of survival analysis as a regression problem, where we have on one side the response variable, and on the other side we have the covariate or the predictors. Okay? So in this case, the response variable in survival analysis or time to event analysis is the time until a specific outcome occurs. Okay? And from my last video, my last post, okay, we learned that that event can be death, disease, relapse, recovery, or think of any defined endpoint. Okay? And think of an event, if you want, broadly speaking, as the answer to a yes-no question. What does it mean? If I ask you, for instance, did you go to the gym yesterday? Your answer should be yes or no, right? If I ask you, are you still alive? Your answer should be yes or no, because you have to be alive in order to answer my question, right? If I ask you, do you like me? Either you like me or you don't like me, but I don't care. So, this is how, okay, we define event, broadly speaking. So, the response variable is the time until an event occurs, and the predictors are the explanatory variable or the covariates, okay, are any characteristics, any features, anything that you can think of that may affect or impact the timing of the event that you're studying. Okay? Let's say, for instance, that our population consists of human beings. Okay? So those predictors can be your age, your sex, your height, your weight, your BMI, body mass index, your cholesterol level, right? And we can even go further and record your smoking status, whether or not you smoke, okay? We can also keep track of your diet, right? Whether you eat healthy or not, whether you exercise or not, and so on. Anything that can potentially affect your survival time, okay? Assuming that the event in this case is death. So, if we assume that the survival time is continuous, because of course we can have continuous survival time, discrete survival time, or even a mixture of both, okay? So, in this case, we assume that we have a continuous survival time. So it can be in seconds, minutes, hours, days, months, years, and so on. So at this point, if we assume that the relationship between the survival time and the predictors is linear, then we can go for a linear regression model and, fit this model to the data set and predict the survival time of a new individual. Okay? But here's the problem. In medical research, for instance, where the goal is to study, okay, the time until some group of individuals or a cohort of individual subjects will die, okay, there are three types of events that may occur. The first one is that we may lose track of one of the patients, and the correct word is, or the correct phrasing is, one of the patients can be lost to follow up. Okay? That is, we can no longer locate them, or we can no longer assess their survival time. We lose track of them. We lose sight of them. Okay? The second event that may occur is that one of the patients can decide to withdraw from the study. So if a subject decides to step back, okay, to withdraw from the study, there is nothing you can do against it. So it means that we can no longer assess their true survival time, the actual survival time. And the last event that may occur is that by the end of the observation period, okay, some of the patient or the subject may be event free. That is, they may still be alive. They may not die. Because for every study, we have to define a starting point, which is the origin, the time at which we start observing, we start recording, we start studying the patients, and we have an endpoint, which is the end of the study. Okay? We can also refer to this observation window as the exposure period. Okay? All right. So, you can see that if any of these events occur, then for the subjects with a censored survival time, we may not know what the true survival time is. Okay? But what we know for sure is that their survival time is at least as long as their observation period. So in this case, their survival time is not missing. We still have some incomplete information about it. So we need to find a way to make use of that information. Okay? So this is where survival analysis comes in. And we treat or we consider those incomplete observations as censored. Okay? So we refer to this phenomenon as censorship or censored data. So if you use this censored data to fit your linear regression model, to train your model, and then use your linear regression model, your traditional linear regression model to predict the survival time of a new patient, for instance, it means that your result will be biased or skewed. Why? Because you did not make use or you did not account for the censored observation. Okay? But with survival analysis, we have special methods or special techniques to handle this type of situation. This is what makes survival analysis so special. Okay? Thank you very much for your attention. My name is Emmanuel Monsabo-Djegu, PhD candidate in statistics at Missouri University of Science and Technology and data science intern at RGA. If you want to learn more about data science, statistics, or survival analysis, you know what to do. Follow me and subscribe. Thank you.